In this video, we will demonstrate how to plot graphs and format them, curve fitting, and how to produce multiple plots. These are useful skills which you should try and use in your own experiments. First, we need some data to plot. Let's make a simple graph of y equals x squared. Let's define the x values as 0 to 5. Notice how it did not appear in the command window because the command was suppressed with the semicolon. Next, define the y variables, y equals x squared. Now use the basic plotting command, plot. This will print a figure showing a graph with the x values on the horizontal axis and the y values on the vertical axis. Both of these arrays had the same dimensions, but if they did not, then the command would have failed. There are a few kinks in this line. These can be smoothed out by adding more points in the same range. Do this simply by decreasing the increment in the x-array. Let's make the increment 0.1. Now we have to recalculate the y values and replot the graph. You can see that the graph is now much smoother. This highlights the importance of having enough data points in your graphs. This was an arbitrary situation, but when analyzing the results of an experiment and trying to fit a relation to it, a few more data points could make the difference. We can alter the appearance of the graph in a number of ways. You will have noticed that MATLAB, by default, joins the points together with a straight line. You can suppress these lines with the following code. This will show each individual point as an X. The color of the markers can be changed, which allows you to plot multiple graphs on one set of axes without confusing them. The color specification comes in the same place as the marker shape definition. This will plot the points as red X's. More details on the different markers and colors can be found with the command help plot. It is vital to annotate your graphs with a title and labels on both axes. This can be done either from the command window or in the figure editor once you have plotted the graph. We'll give the graph the title quadratic. We have to put the desired title in inverted commas because it's a string, something made up of alphabetical characters. When inverted commas appear in MATLAB, it means that you want exactly what is typed between them to appear in the result. They are used in many functions like xlabel, which creates a caption for the x-axis, and ylabel, which creates a caption for the y-axis. A legend can be added with, unsurprisingly, the legend command. To use this, type the name of the data series you want in the brackets after legend, and don't forget the inverted commas. If you have multiple data sets, then enter them in the same order as the data was plotted. As mentioned before, all of these changes can be made in the editor. Go to Edit, Axes Properties, and this is where you can edit the labels and the legend. In Figure Properties, you can change the colors of the figure and its title. By clicking on the points, the marker shape and color can also be changed. Now we have a quadratic curve, clearly labeled and well presented. Excellent.
When plotting real data, there will be random noise, which means that you have to try and guess what kind of relation there is between the variables. Here is a noisy graph. For basic fitting, select the Tools menu and then select Basic Fitting. A menu appears with a list of different types of graph. Tick the box next to the relevant graph type to display it on the axis. Clearly that is the wrong relation, so let's try another. The goodness of fit between the different lines can be compared by plotting residuals. This plots a bar chart of the difference between the point's location and the distance in the y-axis from the fit line. It may be the case that you have different data sets that you want to compare. This can be done either by putting the graphs all on the same axis with the hold command, or they can be plotted in the same figure but on different axes with a subplot. Let's plot sine and cosine. We'll define the angle from minus 2 pi to 2 pi, remembering that MATLAB works in radians. We know how to plot a single graph, but to plot another variable on the same graph, we have to type hold on as a command in the command line like this. Now plot the other variable in a different colour to distinguish more easily between the two. Let's now add a legend to the graph. We put the series names in the same order as the data was plotted. You can clearly see the two graphs on this one figure. To print to a new figure, you have to reissue the command hold off. Alternatively, you can just type hold to toggle hold on and hold off. Now we want to have the graphs side by side, which demands the use of the subplot command. This may be useful when you have graphs which are related but are on different axes with different units, like velocity and acceleration. The command works by entering three numbers. The first number indicates how many rows you want on the figure. The second number gives the number of columns, and the last number is which subplot you want to print to when you execute the next plot command. Now we are printing to the second subplot in the figure, so we use 1, 2, 2. Now they appear side by side. You can have as many subplots as you like, and you can experiment to see how you would get these graphs to be one above the other and what happens if you introduce more graphs to the figure.